What's up, my pre-calc people? In this video, I want to take a look at a couple multiple choice questions that come out of Unit 3 over trigonomic and polar functions. Let's take a look at them now. Before we begin, I want to remind you that all of these questions were taken from the AP Precalculus course and exam description, which means they're pretty much very similar to questions that you're going to see on the exam. Now, they also tell us in that same exact course and exam description that 30 to 35% of the multiple choice questions will be over trigonomic and polar functions. That is the biggest chunk, so definitely expect a lot of questions dealing with trigonometry. Let's be ready for them. All right, let's take a look at the first problem here. Let f of x equals 1 plus 3 secant x and g of x equals negative 5 in the xy plane. What are the x coordinates of the points of intersection of the graphs of f and g on the interval 0 to 2 pi? All right, so we're thinking, okay, they want us to find where they intersect. That means where the two functions are equal. 1 plus 3 secant of x equals negative 5. All right, so when we're dealing with trig functions, the first thing we have to do is isolate the trig function. So I want to isolate the secant of x, and I'm going to subtract 1. That's going to give me 3 secant of x equals negative 6. Then I'm going to divide by that 3, and I get secant of x equals negative 2. Now, most kids aren't necessarily as familiar with secant or cosecant or tangent as they are with sine, cosine, and tangent. So I'm going to go ahead and change this secant to a cosine. Well, remember, secant and cosine are just reciprocals of each other. So if I decide to use a cosine instead of a secant, all I got to do is take the reciprocal of negative 2, which is negative 1/2. Now I get some values that I recognize. Negative 1/2, you should definitely recognize. Again, this is on the no calculator section. So again, I like to think about that unit circle, and I tell kids, listen, when you get that test, draw a unit circle. It doesn't even have to be pretty. But where do I see an x coordinate from the unit circle of negative 1/2? That's going to be right here and right here. Now, they only want us to give solutions from 0 to 2 pi, so I don't have to worry about adding anything onto this to compensate for the infinite answers. But hopefully you guys are good at recognizing that, however your teacher taught you. But there are two answers at 2 pi over 3. That's the answer up there in quadrant 2. And there's another answer in the third quadrant of 4 pi over 3. So that makes our final answer choice C. All right, in this next question, we see a sinusoidal function g. What are the values of the period and the amplitude? All right, there's so much that we could do with a graph of a sinusoidal function, and the easiest things are identify the period and the amplitude. So first, let's figure out the period. Now, I like to find midline first. Even though you weren't asked, I like to find the midline first. So the highest point is 3, the lowest point is negative 3, and that middle of that is going to be where that midline is. So if you add 3 plus negative 3 and divide by 2, the dead center of that is going to be 0 divided by 2, which is obviously 0. So we see that we have a midline here at 0. Just kind of casually draw that in. All right, now the reason why that's important is because the amplitude is how much you go up or down. It's the distance you go up or down from that midline. And of course, that distance is going to be 3. So I definitely have an amplitude of 3, so I can immediately get rid of C and D that said an amplitude of 6. Now, what about that period? Well, what I need to do is I need to recognize one full cosine or one full sine curve. Either one works. I see a cosine curve right away. Cosine curve starts at its max, comes down to its min, and then back to its max. That's one full period of a cosine. And I asked myself, well, how long did that take? Well, it started at 3, and that ended at 11. So that is a period of 8. So there we go. B is our final answer. The period is 8 and the amplitude is 3. Pretty simple there. Now, you could also find a cosine curve if you would like. Let me go ahead and find a cosine curve. Excuse me, I found a cosine curve. We could find a sine curve. Now, sine curves start on their midline, so I could start right here on the midline, go up to the max, all the way down to the min, and back to the midline. That would be a distance from 1 to 9, but that's still a period of 8. So that doesn't change my period, even though I looked at a different value there, or a different curve there. All right, that's it for that one. Pretty simple, I think. All right, this problem, just by looking at the choices, and by the way, these choices, these graphs were much bigger on the actual exam, so you can maybe see them a little bit better. But clearly, this is going to be dealing with polar functions. If you've done that lesson on polar functions, you recognize these graphs for sure. All right, which of the following is possibly the graph of 3 cosine theta plus 2? Now, I don't know exactly how you learned this, but I like to put that 2 in front. So I like to look at this function, and it really doesn't matter. It's not going to change the answer. But I like to put that 2 in front. 2 plus 3 cosine of theta. Now, I like to look at that 2 as my A and that 3 as my B. Now, here's a couple things I know. And again, all depends how you learn this in your particular class. But if we take A divided by B, In this case, actually it's the absolute value of both of them, but if in this case that's 2 divided by 3, and if you get that value, that ratio of A to B, and if that value is less than 1, which it obviously is, 2/3 is less than 1, that means that you're going to have an inner loop on your polar function. So I can immediately get rid of A and C just because they don't have that inner loop that I see in B and D. All right, now let's talk about that inner loop. Well, a couple characteristics. First, the A value is how far you are on your y-axis, up and down. So we see right here, we see a +2 and we see a -2. So that's pretty quickly going to tell us that our answer is D just based on that alone. If we look at choice B, we don't have those y-intercepts at that A value. Now, just a couple other characteristics that I hope you learn in class. If you add the absolute value of A and B, we get 5. That's going to be the biggest value going to the right. Oh, by the way, I should mention, how do I know that the graph is going to the right? Well, because that's cosine. Cosine goes to the right or to the left. Sine goes up and down. So the fact that I see it going to the right, now they all go to the right, but that tells me it's a cosine. And then the inner loop is that the subtraction or the absolute value of 2a minus b, which is 2 minus 3. So that's going to be at the absolute value, which is 1. So that's where we see that inner loop go to 1. So that's a clear sign that D is my answer for this polar graph. All right, next problem here says, what are all the values of theta from -pi to pi for which 2 cosine of theta is greater than -1 and 2 sine of theta is greater than radical 3? Now, I got to be honest with you. I think solving trigonomic inequalities is one of the trickiest things. So I'm going to really take my time on this problem to make sure I explain it well. And I definitely think a picture is worth 1,000 words. So before I even start analyzing those inequalities, I'm actually going to draw a picture of the unit circle here. Just going to draw a picture of our circle. And they want me to get answers going from -pi all the way to +pi. So that's kind of how we're looking here. So we're looking at going down to -pi or over to +pi, which still incorporates the whole circle here. All right, so let's think about this first one here. So 2 cosine of theta is greater than 1. So I got to divide by 2, and I get cosine of theta is greater than -1/2. So I'm thinking, okay, where is cosine -1/2? Again, that's why the picture really helps here. Cosine is -1/2 right about here. And if you know your points well from that unit circle, you know that that's going to happen at 2 pi over 3. And then again, this one down here at the bottom right here is 4 pi over 3. But remember, based on the restrictions, I either go around to pi or around to -pi. So 4 pi over 3 is not wrong. It's just it's the right spot, but it's the wrong value. So that the value that would go down to get to this point right here would be -2 pi over 3. Okay, so this means that my angle is in between there. Now, I got to think about what this says. We want the cosine value to be greater than -1/2, right? So if this is -1/2 right here, greater would be all of these values over here. So the solution to just this inequality would be all of these values over here, all of these angles from -2 pi over 3 to +2 pi over 3, right? So I kind of have my inequality drawn wrong here, but you get the idea that my answers lie between -2 pi over 3 and +2 pi over 3, because that's where my cosine value, the x-coordinate, is greater than -1/2. Greater is to the right. Okay, but I got a second inequality to deal with as well. So let me go ahead and divide by 2. So I get sine of theta is greater than radical 3 over 2. Okay, so now I can say, where is sine radical 3 over 2? This is where it gets a little bit confusing, so bear with me. I know my picture's not great. But sine is the y-coordinate, so radical 3 over 2 is right here. Now that's going to happen, at 2 pi over 3 as well. Okay, that's awesome. That's good. But it's also going to happen right here at pi over 3. Right there at pi over 3, I also have that sine value of radical 3 over 2. And I want to be greater than radical 3 over 2. Well, okay, greater than radical 3 over 2. Once again, here, right here, here's radical 3 over 2 on my y-axis. If I want to be greater, I'm looking at any value that is right in here, right? All of these values in between are going to be greater. Hopefully that makes sense. So anywhere, so this inequality right here by itself, we're looking at any value from 2 pi over 3 to pi over 3. Any value in between there is where I'm going to be greater than radical 3 over 2. But now they want me to find an answer that satisfies both of these. So that would be what I have shaded in yellow, because that's satisfying sine greater than radical 3 over 2. But that section is also the only section that also satisfies cosine being greater than negative 1/2. Just to show you here, an angle like right here, this angle would have a cosine value greater than negative 1/2, but it would not have a sine value greater than radical 3 over 2. So that means my final answers are from the 2 pi over 3 right here to the pi over 3 right here, and that's going to be choice D there. So again, a pretty tough question, but hopefully I did a pretty good job explaining it. All right, this next one also deals with the polar function. So a polar function is given by r equals f of theta equals -1 plus sine of theta. As theta increases on the interval 0 to pi over 2, which of the following is true about the points on the graph? All right, so they're saying the points are above the x-axis, C and D say below the x-axis, and then we are getting closer to the origin or getting further from the origin. So the first thing I want to do when I think about this problem is, what's the graph of this look like? So I actually spoke about this earlier when I think about that A plus B sine of theta form here, right? Okay, so first off, I'm thinking about this graph, and it is sine of theta. So that means I'm going to be opening on the y-axis, and it's a positive b value, so I'm going to be opening up. Now, the other thing I got to figure out is, what's going on with this particular shape? Well, remember, if I take the absolute value of A and I divide it by the absolute value of B, in this case, that's going to be 1 divided by 1. If I get equal to 1, if that ratio is equal to 1, that means I'm a cardioid, right? That's where we're going to see this shape, where just rough picture of it, going to kind of look like that heart that goes in there to the 0, to the origin. Something along those lines. Again, it's centered around the y-axis because it's sine, and because that ratio of A to B is 1, we get that cardioid shape. Now, what's happening from 0 to pi over 2? Well, this is where it gets a little bit tricky. So first, let me start off with 0. I actually think about what happens when I plug in 0. So I get -1 plus sine of 0. So I think, okay, so what happens when I plug in 0? Sine of 0, I hope everybody knows, is 0. So I get -1. -1 plus 0 is -1. So that means I'm starting right here, starting at -1 right there. Now, what about the end, pi over 2, right? So now let me plug pi over 2 in. -1 plus sine of pi over 2. Now, sine of pi over 2 is 1, so I get -1 plus 1, which is going to result in 0. So that means I end over here. Now, that means I'm getting closer to the origin because I started at -1 and I ended at 0. So I got closer to the origin. I'm not getting further. So I could get rid of B and D. Now, is the graph above or below the x-axis? So to answer that, all you got to do is plug in a value that's somewhere in between 0 and pi over 2. A great answer would be pi over 4. So if I take -1 plus sine of pi over 4, pi over 4 is negative radical 2, or not negative, I'm so sorry, positive radical 2 over 2. And if I add those together, I'm going to get a negative number. Radical 2 over 2 is more than 1, so -1 plus a number more than 1. You're going to get a negative result, which means that this is the section right here that I just graphed. I started at -1, and I went through there getting closer to the origin, and then I actually ended up at the origin. So this means that my correct answer is going to be C, because the points are below the x-axis. In that particular part of the graph, I'm below the x-axis, and the points are getting closer to the origin as I progress through that interval 0 to pi over 2. So a lot to kind of soak in there, but that's a really good problem with the polar functions. And I know polar functions is kind of like at the very end of the course, so hopefully you got a good job explaining it, but there's a lot going on there. All right, these next 3 and final 3 problems all deal with calculator-based questions, because that's why we got that big old calculator there to let you know that this was on the calculator section. All right, the number of minutes of daylight per day for a certain city can be modeled by the function d. So there it is, kind of an ugly cosine function, but hopefully we understand what all those transformations are. Where t is the day of the year from 1 to 365, which of the following best describes the behavior on day 150? Now, this is a calculator-based question, so my recommendation is to graph it on your calculator. it's going to really help you see exactly what's happening at day 150. So pull out your 1094 calculator, go to y equals, and graph it. Just please make sure you take your time typing it in. So I did that. I typed it in. I got nice little fractions and parentheses going there. I mean, you miss a parenthesis, something really wrong, big can go wrong. So take your time with that. Now, before I actually hit graph, I kind of need to adjust my window so that it makes sense. So the first thing I think about is my x's, right? My x's are what they're calling t in this problem, and those are the days going from 1 to 365. So it makes total sense to start, well, it could start at 1, I started at 0, but going my x-min from 0 to my x-max 365, and that should be the period. If you actually do the math on the problem, that is the period. Of course, 1 full year, right? All right, then I think about the y's. Now remember, the 729 on the back is my midline, and from that midline I go up by the amplitude of 160, and I also go down 160. So I kind of want to get a nice view of this. So I just had a y-min of 500. I figured 729 minus 160, just want to go a little bit lower than that, so 500. And then I also wanted to go a little bit above the max, but 729 plus 160, so I went to 900 just to get a nice, look at this. So go ahead and hit graph, and there it is. So we see that as the day goes on, the minutes get longer, and then they hit a peak, probably in the summertime, where the minutes are at the day of the longest, and then they come back down. All right, now the question's saying, what happened at 150? Well, this is why your calculator is awesome. Because if you hit that trace button, and then you could literally just start typing in 150, and it's going to shoot you exactly to 150. So there is my blinking point at 150. So the first thing I think of is, okay, at that point, what's happening? Well, I'm on the up and up, right? The left-hand side of this graph, I'm going up, going up. So I'm definitely increasing at that point. Now I'm getting close to that max, so I'm going to start decreasing, but on that side, I'm still increasing. So I can immediately get rid of B and D that say decreasing. Now I'm thinking about how is it increasing? Well, if I think about the slope of the tangent line at that point, and then I go a little bit to the left and then a little bit to the right, we realize that it is decreasing. I'm increasing at a decreasing rate. Now, the other thing I realize is where that blinking point is at, I'm concave down. And that's literally the definition of what concave down means, is that your rate of change is decreasing. So at that point, I'm on the up and up, I'm increasing, but I'm at a part of the graph that's concave down, so I'm increasing at that decreasing rate. That's going to make choice A pretty easy to make. Not too bad. All right, next question here. The function g is given by g of x equals sine of x minus cosine of x and has a period of 2 pi. In order to define the inverse function of g, which of the following specifies a restricted domain for g and provides a rationale for why g is invertible on that domain? So we want to figure out what I have to restrict the domain for so that I could go ahead and actually use this as a function. Use the inverse as a function. Now, keep in mind that the whole reason why we have to restrict inverses is that we don't have repeated intervals, right? When you have a function, the rule is you're only allowed one output. But if we switch an angle instead of an input, as an input, angles can be infinite, and that angle now becomes an output, we have infinite angle options. And we're not allowed to have infinite options for an output. So the reason why we restrict is that we don't have repeated values. So I can immediately think that the answer is going to be A or B just because the rationale for C and D about half the period, that's just not correct. It's all about stopping repeating values from occurring on that interval. So now I got to figure out what the interval is that's going to be correct. So what I'd recommend doing is graphing it. So go ahead and pull out that calculator, go to y equals, and graph it. All right, so in y equals, I type in sine of x minus cosine of x. Make sure you're in radian mode, please, as well. Your calculator should be in radian mode the entire course and the entire exam. Now, the other thing I'm going to do is I got to adjust that window, right? So they said that the period is 2 pi. So I actually went for a minimum of negative 2 pi and a positive of positive 2 pi, just so that I kind of get a little nice view of this all. And then for the y min and max, I mean, typically we go up to 1, down to 1, but I kind of just spread it out a little bit more to kind of just see it. I went negative 3 to 3. Now, the other important thing here is the scale, right? For the y scale, I'm going to make it something like 1. That makes it pretty simple. But for the x scale, when you're working with radians, pi over 2 is pretty common. You could even do pi, but I'm going to do pi divided by 2 here just to kind of get a nice scale for what my tick marks on my x-axis are going to be. That's actually going to matter a lot here. All right, so if I look at this graph, I got to choose a portion that is nothing's repeated. Like my values are not repeated. So to talk a little bit more about this, actually I'm going to copy this graph into my document here. And there it is. Now I can talk a little bit more about it. All right, so here's the deal. We want to make sure that we do not repeat values. So if I'm looking at the two options here, the first one says 0 to pi. Now remember, I had this go to 2 pi. So if I go from 0 to pi, this would be pi right here in the middle. That would be my pi, because I remember I set the graph to go to 0 to 2 pi. Now if I look over there, values get repeated. Like, this value right here is repeated over here. There's lots of repeats from 0 to pi. That's going to be a problem. So that actually cannot be the answer. Now the other one is negative pi over 4 to 3 pi over 4. So again, remember, each of my tick marks are pi over 2. So in between the tick marks would be pi over 4. That makes sense. So right here from negative pi over 4, which would be right there, to positive 3 pi over 4, which would be right here. Yeah, now there I go. There is a nice portion of the curve that doesn't have any repeated values. If I only restrict my domain to that particular domain, negative pi over 4 to 3 pi over 4, none of the y values get repeated, which means it's invertible. As long as there's no y values repeated, when I inverse it, I will only have one output for every input, which is exactly what I want. So, it's nice that I can figure out that B is the final answer by thinking about it, but I can also kind of eliminate some choices just by understanding, what I've been learning about inverse sine and cosine and how they all come together. So the correct answer on this problem is B. Pretty good problem there. All right, this last one is another calculator-based problem, but I actually think you should be able to do it without a calculator. All right, a theme park thrill ride involves a tower and a carriage that rapidly moves passengers up and down along a vertical axis as shown in the figure. The carriage is lifted to the top of the tower, then released to move back down and so forth. The ride involves 10 controlled bounces from the highest point to the lowest point and back to the highest point. At point X is located at the bottom of the carriage. They clearly show us we have a point X here. And the height of X above the ground in feet can be modeled by a function. That's what they want us to do, is figure out what function models the height X is above the ground. Now they tell us a couple things. At time 0 seconds, we're at its highest point of 120. So at 0 seconds, we're at the highest point of 120 seconds. And at the lowest point, we're at 20 feet. But they don't tell us the time for that. But they do tell us the next time we're at the highest point is 8 seconds. So at 8 seconds, we're back to that high point. So right away, I'm thinking, first of all, I'm looking at my choices. I got some sines, I got some cosines. Well, what function starts at its highest point and then one full period later ends at its highest point? Well, that's cosine. Cosine starts at its highest, it drops down to its min, and back to its highest point right there. So it makes way more sense this is going to be a cosine graph as opposed to a sine graph. So I could kind of eliminate A and C just by thinking about that. Now, let's talk about the bottom point. Now, the bottom point they did tell us is 20 feet. They said the lowest point it's going to be is 20 feet, and that's going to happen right smack dab in the middle. So at 4 seconds, I'm going to be at that 20 feet. Now, what about the midline? Well, the midline is going to be going right through the middle. So what's the middle of 20 and 120? 70. That's my D value. Now, that doesn't help me eliminate any choices, but I definitely understand where that 70 came from now. Now, from that 70, I go up 50 to the 120, and I go down 50 to the 20. That's that up and down. That's that amplitude. Well, once again, they all had an amplitude of 50, so that doesn't change that. Next up is the period. The period is 8 seconds. That's the period. Now, the formula to find the period is 2 pi divided by b. This is going to allow me to solve for my b value, because if I look at the two choices I have left, b and d, the only difference is the b value. So now I'm going to solve for it. Again, I took my period, 8 seconds, set it equal to 2 pi over b. Multiply the b to the left-hand side, divide by 8, and I get b equals pi over 4. So there we go. The correct answer is B. It's the only one that has the proper midline, the proper amplitude. It's cosine, which makes a ton of sense for the graph based on starting at the max, ending at the max. And then, again, that B value is pi over 4. All right, and notice I didn't touch a calculator for that question. I mean, I guess at the end of the day, you could graph these to kind of make the choice, but to me, that's a little bit more time-consuming checking and graphing, where if I just think through it, I can get to that answer. All right, so again, I know we looked at quite a few problems in this video because, well, the trigonometric and polar function section of the multiple, well, there's not going to be a section in the multiple choice just for these problems, but they're all mixed around. There's more of them. There's 30 to 35%, so that's a lot. So hopefully taking a look at a couple of them is going to be really beneficial to you for the exam.